Welcome back to the Explainer. Today we're going to talk about a threat that is, believe it or not, almost as old as the commercial internet itself. And yet, it's still one of the most powerful tricks a hacker can use. It's called SQL injection. And what's wild is that it's not some super complex attack. No, it's a surprisingly simple bit of cleverness that has been used to steal billions of records. We're talking everything from credit card numbers to your most personal secrets. So, that brings us to the big question, right? How on earth can something as ordinary as a login form or a search bar on a website become a master key to a company's entire digital vault? Well, the answer is as brilliant as it is terrifying. You trick the application into betraying itself. Okay, let's break that down. At its core, SQL injection is when a hacker slips malicious computer commands into a totally normal input field, like a username box. The application, you see, it just can't tell the difference between what's supposed to be there and the malicious command hidden inside, so it just runs the command. It's kind of like going to a library and asking for a book, but you phrase your request in such a sneaky way that you trick the librarian into just handing over the keys to the entire building. All right, let's dive into the nitty-gritty of how this digital heist actually works. The real secret here is all about blurring the lines between two very fundamental things, plain old data and powerful commands. See, anytime you interact with a database, there are two parts to the conversation. There are the commands, the instructions for the database, and then there's the data, which is the information the commands are supposed to work on. The whole vulnerability, the very heart of SQL injection, is that an attacker can disguise a command to look like data. And if you can pull that off, you can basically trick that database into doing almost anything you want. So let's look at a real example. Over on the left, you've got a normal, safe login. Somebody types in their name, Susan, and the database query just looks for a user named Susan. Simple, right? But now look at the right. This is the hacker's brilliant little trick. They don't just type a name, they type a single quote, which basically tells the database, hey, we're done with the name now. Then they add a new condition, or 1 equals 1. Now think about it. When is 1 not equal to 1? Never. So that condition is always true. That double dash at the end, that's just a comment signal telling the database to ignore anything else that might come after it. And the result? The query's logic is now broken. It just returns every single user in the system because the hacker created a condition that is literally always true. And that's really the playbook. It's a simple, four-step process that's been used to steal billions of records. You find a weak spot, you craft that malicious little string, you inject it, and then you just let the application's own code do all the dirty work for you. It's kind of a testament to the power of simple, elegant design, even when it's used for something pretty evil. Now, this isn't just some abstract threat we're talking about in a textbook. SQL injection has been the weapon of choice in some of the most massive, most devastating data breaches in history, with real-world consequences that have affected millions and millions of people. This timeline really shows you just how persistent this threat is. I mean, look at this. Way back in 2009, Heartland Payment Systems got hit. In 2011, it was Sony, with over 1 million accounts exposed. And then you jump all the way to just last year, 2023, and the huge MoveIt breach showed that even modern systems are still falling for this old trick. The takeaway here is crystal clear. Even though we've known about this for decades, SQL injection is not going away. Just let that number sink in for a second. 130 million. That's how many credit card numbers were stolen in that Heartland attack alone. That's 130 million people who had their financial security completely compromised, all because of one single, pretty simple vulnerability. It's just staggering. Okay, but the good news, and there is good news, is that this is a totally solvable problem. We absolutely know how to defend against SQL injection. There are proven, effective ways to lock that digital vault and keep our data safe. The best defense is always a layered one. Now, the most important strategy, the real game changer, is something called parameterized queries. It's a programming technique that basically forces the database to treat commands and data as two completely separate things. It builds a wall between them so they can never get confused. Then you've got input validation, which is kind of like having a bouncer at the door, checking every piece of data that tries to come in. And finally, there's the principle of least privilege, which just means that even if a hacker does get in, they're stuck in a room with very limited access, so they can't do much damage. And hey, don't just take my word for it. There's a nonprofit called the Open Web Application Security Project, or OWASP. These folks are basically the world's leading experts on this stuff, and they're really clear. They say that using those parameterized queries is the single most reliable and effective way to stop SQL injection attacks, period. So after all of this, what's the one thing you should really remember? How can you explain this whole idea to your friends? Well, as it turns out, there's a famous internet comic that does a better job of explaining this than I ever could. This comes from the webcomic XKCD, and it's a classic. A mom gets a call from her son's school. They say, "We're having some computer trouble." She asks what happened and then explains she named her son Robert, drop table students, semicolon. The school, of course, just entered his name into their student database. The database saw the drop table students command and, well, it dutifully deleted the entire student database. It's hilarious and, frankly, a terrifyingly accurate illustration of how this works. And it's why you'll often hear this attack affectionately called Bobby Table. And that leaves us with this huge paradox, doesn't it? We've known about SQL injection for decades, we've proven ways to prevent it, and yet year after year, it continues to be one of the most common and destructive cyber attacks out there. Why is that? Well, the answer is complicated. It's got to do with old legacy systems that are hard to fix, the constant business pressure to release software fast, and of course, just plain old human error. It's a really powerful reminder that in the world of cybersecurity, sometimes the biggest vulnerability isn't in our code, but in ourselves.